All right, so in this one, the way I would do this problem is I would first work with just the variables and try and get it to the point where my unknown, where I have the mass isolated, because that's the unknown. Now I'm going to get the mass because the mass is part of the moment of inertia. So looking at what I have for facts, I'm going to have a turntable platter has a radius of 0.230 meters and it's rotating at 45 revs per minute. When the power is shut off, the platter slows down and comes to rest in 13 seconds due to a net retarding torque of 7.6 times 10 to the negative third Newton meters. Now, retarding torque means it's slowing it down. So I will write that as a negative number if it's a retarding torque. Now, the negative there doesn't mean clockwise. The negative there means slowing down. So you have to know the context of the sign in the problem. In this problem, it doesn't really matter. We're not really concerned with is it rotating clockwise or counterclockwise. It's just we know it's rotating, and the torque will be causing it to slow down. So it says assume the platter to be a uniform disk. A disk is the same thing as a cylinder. It's just a flat cylinder. So you're going to use the same formula for a cylinder, for a disk as you do for a cylinder. So know that. I don't want anyone coming up to me during the test saying, what's a disk? I don't have the formula for a disk on the formula fact sheet. Right? We've done it up, we've done these where I've said that a few times. So first thing, let's see, I'll list my facts. So we know the radius. So the radius is 0.230 meters. And it's rotating at 45 revs per minute. So the omega, 45 revs per minute. I think there's another problem on the test that has revs per minute. I don't want you to be wasting time doing all these conversions. So I think I was telling somebody that I'm going to go back to the test and just change it to radians per second, so you don't have to. I mean, maybe one conversion on the test, but not where every single problem you have to convert revs per minute into radians per second. Okay, so with this one, I'm going to have to do that. So I'm going to go from revs to radians and minutes to seconds. 60 seconds in 1 minute. In 1 rev, 2 pi radians. So that comes out to be what? Like 4.71? All right, so I have the omega, which would represent the original angular velocity because that's how fast it's going. The power shut off and the platter slows down and comes to rest. So we know the final angular velocity is 0 radians per second. And it does that in 13 seconds. So I have to do a rotational kinematics problem to get the alpha. If I know these 3 facts, I can use them to get the alpha. And let's see, the net retarding torque in the problem is, so I'm going to write it as a negative. Oops, I need to say it again. 7.6 times 10 to the negative 3 Newton meters. And we're going to be looking for the mass of the platter. So that's the unknown. That will give me the answer in kilograms based on the units for everything else in this problem. So I know that the mass is related to the I. All right, the mass is related to the I. So I've got the R, and I'm going to get it from figuring out the I. Now I can figure the I out separately, and then once I have that figured out, or I can just combine. But the first thing I want to do is get alpha. So I've got this fact, and this fact. So if I'm using those 3 facts, I'm going to use those to solve for alpha. So alpha is what I'm looking for first. So the formula, I'll write it as an unknown. It's not really my unknown. It's not my ultimate unknown, but I do need to solve for it. So that's my unknown, and I've got the 3 facts above. So I'm not going to rewrite the facts. What formula would I use with those facts? What's my formula? omega F equals omega O plus alpha T. And omega F is 0, and I'm solving for alpha. So alpha is going to be minus omega O divided by T. I'm going to move the omega O to the other side and then divide by the T. So there's my equation. Plugging in the numbers, and you're going to have minus omega O divided by T. So the original was 4.71 radians per second, and the time is 13 seconds. So my answer will come out to be negative because it is slowing down. So the negative here doesn't mean clockwise, it means slowing down. And what do you get for that answer? 0.362 radians per second squared. So there's my alpha. So now, with all these numbers that I have, I'm going to get my mass directly. I'm not even going to solve for what I is, I separately. I'm just going to, again, you can if you want, but I want to go right to solving for the mass. So I'm going to do this. I'm going to take my equation, my Newton's second law for rotation, torque equals I alpha, and I'm going to replace the I with the formula for I in this problem. So in this problem, they said it was treat it as a uniform disk, which is a cylinder. And what's the formula for the moment of inertia for a cylinder? 1/2 mr squared. So this formula is going to become 1/2 mr squared alpha. So I'm replacing the I with 1/2 mr squared and then times alpha. So if I check things out here, I know what the torque is, I know what the R is, and I know what the alpha is, so I should be able to rearrange this equation to solve for M. So if I do that, I'm going to get, well, I want M. So I multiply both sides by 2 will get me the 2 up here. And then I'm going to divide by these 2, and that would get me M by itself. So I'm going to get M is going to equal 2 tau, so 2 times the torque, divided by R squared alpha. So I'm not even solving. Again, if you want to get I separately, you can, because we do know M and we do know R, but if I do it this way, I don't have to solve other than for the unknown. I mean, I had to solve for alpha up above, but I don't have to solve for I here. So I'm going to get 2, and then the torque is minus 7.6 times 10 to the negative 3. Just to show the units canceling out, I'm not going to write it as a Newton meter. I'm going to write it as a kilogram meter squared per second squared. All right, because a Newton is a kilogram meter per second squared times a meter would get me that. And then I'm going to divide that by the R in the problem was what? 0.230. So 0.230 meters squared. And then the alpha is negative. So notice the negatives will cancel out here. Negative 0.362 radians per second squared. And if I look at what cancels out here, I have kilogram, will not cancel out with anything here, but the meter squared will cancel out with the meter squared here. The second squared will cancel out the second squared. So my answer will be in kilograms. So when you do your algebra, you want to make sure that the answer does end up in the unit you expect it to be in. You know mass is measured in kilograms. So what do you get when you work that out? Now, putting this in your calculator, you should go 2 times that divided by that squared divided by that, because they're both below the fraction line. What do you get for that? It's like 0.794. All right, so 0.794 kilograms. Any questions?